Thank you very much, and thank you everyone for sticking with me to the last talk. Today I'm going to talk about forecasting exposure to tropical cyclones and via emergency bulletins. And by emergency bulletins, I mean that we're producing reports shortly before tropical cyclone landfall on potential flooding and who might be exposed and where to that cyclone. And we're providing those then to FCDO here in the UK, and then that's been disseminated to various partners they have, such as OCHA and others. So we're dealing with the situation just before a tropical cyclone hits. Before I talk about the emergency bulletin, so I'm going to talk a little bit about our research in Bristol and why we got into this. So one of the main things we do in our group in Bristol is we develop a flood inundation model that we actually apply globally. So it looks a bit like this over the continent of Africa. What you have is estimates of return period, so a hazard map for entire continents, where for every 90-meter pixel of that continent, we're attempting to estimate the probability of flooding in any given year, or the return period flood. And the system works a little bit like the diagram on the left here. So we have an analysis of the hydrology, in this case, what we call a regional flood frequency analysis, which provides us basically estimates of the likelihood of various extreme discharges occurring on every river in our model. And that's all rivers over 50 square kilometers in this case. And then the bit that we develop in Bristol is that we then translate those estimates of river flow into flood inundation via something called a hydrodynamic model that simulates the 2D basically spreading of that water over the land surface to produce the map that you see here. Just to give you a sense of what this then looks like, a little bit to the south, I'm sorry I don't have an example for Malawi, but here we see our global flood model in Zimbabwe, and this is the 2015 version of our model. So the first version of the model that we produced, in fact, and here you can see a river. It's a little bit blocky, but you know, the floodplain is clearly delineated. By 2019, we'd cleaned up the digital elevation model that we were using a little bit, improved this model somewhat, and now in 2022, our latest release of the model, we've moved to 30-meter resolution globally, and changed the elevation model to something called the Copernicus stem. And here we're now starting to resolve the river channels themselves. You can see in here, you can see features on the floodplains. Yeah, we're pretty excited about this latest generation of our model, which runs everywhere. The other thing this model allows us to do is start to look at pluvial flooding as well. So this is flooding from heavy direct rainfall, and here you can nicely see the kind of drainage network of this area that becomes active during very intensive rainfalls, like you might see from tropical cyclones. So that's the research we do. I won't go into the details of how we do this modeling, but please do get in touch if you want to know. And so the focus of this work is then, well, how did we apply this this modeling work to the case of basically responding to tropical cyclone emergencies? So here we see a picture of Cyclone Eloise, which hit Mozambique last year, and some of the resulting flooding that came from that. And tropical cyclones are a source of multiple hazards. You've got coastal storm surge, you've got high winds, but also fluvial and pluvial flooding, and indeed increased landslide risk as a result of these storm systems moving through. And in today's talk, I'm going to talk about just how we simulate fluvial flooding for these. So we first got into writing these bulletins as a result of Cyclone Idai in 2019. And we were approached by the UK government, who wanted a forecast of the exposure and potential resources at risk in order to help them respond to this event. And it was a bit of a rush because they contacted us and we asked them when they wanted this by, and they said by mid-afternoon tomorrow at the latest. So this was the day before the cyclone hit Mozambique. And so we very quickly formed a small team made up of us at the University of Bristol and a company called Fathom, who do the flood inundation modelling, University of Reading and the European Centre for Medium Range Weather Forecast, who do the forecasting and the hydrological modelling, and also HR Wallingford, who were doing coastal storm surge modelling. And FCDO basically have funded this group since IDITO, who in total now respond to 8 tropical cyclones on their behalf. The most recent in Malawi was Tropical Depression Anna, and Bastirii and Manti in Madagascar this year also. So what does this system look like? Well, it's the starting point is flood forecasts that come from the European Commission's Emergency Management Service. They use a model called GLOFAST that takes weather forecasts from ECMWF and it produces river flow forecasts for these. And what you can see on this map here is the dashboard for this system, where wherever a river in the world is doing something a little bit extreme, a symbol will turn up and that will alert the user that there's a potential case of flooding in that location. And that's driven by the ECMWF forecast ensemble. So here we see an example of that for Tropical Cyclone Eloise last year, and the rainfall totals that we're expecting. The system then converts these into estimates of extreme river flow, and in particular estimates the return period of the extreme flow. So how extreme are the river flows going to be in particular locations? This is what, again, that looks like for Cyclone Eloise. And for points along those rivers, you can pull out the forecast in a bit more detail. And here we see the evolution of the river levels over time that are expected for this event from the present day in total up to 15 days ahead. What GLOFAST wasn't or doesn't provide is estimates of what the flood inundation might be as a result of those extreme flows, or who and what might be exposed to flooding. And this is what FCDO was specifically interested in and why they got in contact with us. And so the element of the work that we work on is then to basically translate those estimates of return period into estimates of inundation extent and the number of people potentially exposed. And so these are 2 examples from Tropical Depression Anna that recently hit Malawi. Here we have the Shire River, location upstream where we had the forecasting system producing a 1 in 20 year flood, and a little bit further downstream where we have a 1 in 5 year flood. And we can see here the inundation extent simulated by a model in blue, and then in kind of brown overlaying that are where those model simulations intersect with population according to WorldPop. We've been starting now to look at the performance of this system and whether it actually works. So here we see that same forecast that we produced a couple of days before the flooding happened, and on the left now a satellite image from Sentinel-1A, which is a radar satellite of the flood extents just after the tropical depression had moved through. So we saw a reasonable degree of agreement between these two. Interestingly, the satellite can't see through vegetation, and that's why on the floodplain down here in the south you see a lot of kind of areas where we predict flooding and the satellite data doesn't, and that's mainly because of vegetation cover and that you don't see the flood extents. And then at a country scale, we're pulling out for each of our reaches where we're forecasting potential flooding, we're pulling out the potential number of people exposed if that magnitude of flood does occur in the near future, and then we're plotting those up and including them in the report. Now, the numbers here I'm pretty skeptical of in terms of the absolute numbers, but the feedback we've had from humanitarians is that we're pretty good at getting the relative numbers about right. So just to finish up, who uses these? We know that they go to OCHA, UNICEF, the World Food Programme, various other groups, and that they were used to help set up various bits of response that happened, particularly to iodine Kenneth in Mozambique. What we don't do is communicate with the public, because that's a role that's taken up by the local forecast agencies. We won't want to interfere with that, but we do share these reports, and they do make it to people in country who can choose to use the information or use their own as they see fit. So that's really everything that I was going to cover. I'm more than happy to take questions. If you want to know more, we also recently published a paper in the International Journal of Disaster Risk Reduction, where you can read about the method and some of the many limitations that it has that I've not had much time to go into today. Thank you everyone for listening, and I hope that was informative and interesting.
Yes, indeed, Jeffrey, many thanks. It was very informative and interesting. Are there any questions? Please post them in the chat for Jeff, in case you would like to clarify something on the effects of tropical cyclones and what can be done. Actually, Jeff, from prediction to mitigating measures, there is some time, in probably more time than we have in the earthquake case, for instance. But what is these measures? What are these measures that can be undertaken in between? Once you issue the warning, let's say, to the authorities.
It's quite interesting. And it depends a lot on the location. So actually, in East Africa, we find that the forecasts, the track of the cyclone tends to be quite uncertain until quite close to landfall. So although we can make forecasts up to 15 days in advance, I would say in terms of doing what we're doing here, where we're forecasting the exposure, our experience is that the forecasts are really only accurate about landfall location about a day or two before landfall. And then by the time you produce a report, you're basically just ahead of landfall when we're getting this kind of information. So if I'm honest, the way this data tend to be used is that the aid agencies and people like FCDO who are responding to these disasters, they tend to be using the information to plan what they're going to do, how they're going to respond, to start moving things into the region, and planning logistics. And in terms of warning to the public, that's generally handled locally. So I would say that this information is mostly being used in the kind of just to get things going, get money out of the door and get the response up and running. It would be great if we could do a slightly longer forecast, but the uncertainties get quite large as it becomes difficult to know how to respond to these events.
Thanks very much. But at least the correlation between prediction and the actual flooding was quite reasonably close, I would say.
Yeah, well, once you get close enough in time, actually, in terms of identifying the locations that were going to be hardest hit, we were pretty good at that. And that did allow, in terms of like, where are the aid teams going to go and visit, and where are things going to be delivered to, that did enable an extra day or two of time to plan out what was going to happen there and respond a bit better.
Okay, so thank you and all the speakers very much.